Hello everyone. In this video, let's discuss about the data types. So here, data types are used to store the different types of values. So here we can say an integer value, a character value, a floating point value, or a string. So here we can store different types of values. To store these different types of values, we have data types. First, we'll take int. It is used to store the integer value. So size of integer is 2 or 4 bytes. Next is nothing but character. To store character value, we have a data type called char. The size of char is 1 byte. And the next one is float. It is used to store a decimal point value. The size of float is 4 bytes. And another, we have one more data type called double. It is used to store decimal points, and the size of double is 8 bytes. So here, what is the difference between float and double is, float is used to store 6 digits after the decimal point. It is used to store 6 digits after the decimal point. But double helps us to store 15 digits after the decimal point. That is the major difference between float and double. In C language, string is not a data type, but I can get string value as input with the help of a character array. When we are discussing about input and output, we'll discuss in detail. So these are all the data types. So apart from this, we have derived data types. So when I say derived data types, those data types are arrays. We'll see in detail. There are two types of array, 1D array and 2D array. Next one is pointers. And next one we call as functions, then structure and union. So these we call it as derived data types. And we have user-defined data types also, like enum, typedef, those are user-defined data types. And next in detail which we have to see is modifiers. We call it type modifiers. So these modifiers are short, long, signed and unsigned. What is the purpose of modifiers in the sense? It helps to alter the size or range of the data type. That is the main purpose of type modifiers. So we can use these type modifiers in front of data types. Okay, so if we are using these modifiers in front of data types, it helps either in changing the size or range of values of the data type. Okay, so that we'll discuss in detail. So here I can take integer as int or short int or long. I can say signed int or I can say unsigned int. So I can use these modifiers for the data type called integer. Now when I go for character, I can say char, signed char, unsigned char. That's all. Signed char, unsigned char. Now when I go for float, we call it as float. That's all. When I go for double, we have double as one data type. Another one is long double. Okay. And user-defined data types, as I have mentioned already, the user-defined data types are structure. We use the keyword called struct, union, enum, and typedef. These we call it as user-defined data types. When I say derived data type, we call it as arrays, pointers, and function. These are called as derived data types. Now let's discuss the modifiers in detail. Okay, as I mentioned earlier, for integer I can give short or just int. I can give either int or short int. Okay, what is the purpose of the modifiers? It helps to alter the size or range of integers. So here I can say the size is 2 bytes and the range is from minus 32,768 to plus 32,767. This is the range of int or short int. Now I want to store more than these values. at that point of time I can go for unsigned int, or I can say unsigned short. So here the size is 2 bytes. What is the purpose of this in the sense? It helps to store only positive values, that is 0 to 65535. So this is the purpose of the modifier. So here I can unsigned, meaning is there is no negative values. When I say integer, if we consider integer as 4 bytes, okay, if we consider integer as 4 bytes, the value is 2, or I can say minus 2147 483 648 2 plus 2147 483 647. I can store this range of values in the data type called integer. Now when you are considering integer as 4 bytes as an unsigned int, so the size is 4 bytes, the range is from 0 to 4294967 This is the thing. Now you have a question, why this range of values alone I can store? It is very simple. The size of integer is 2 bytes. So it starts from 2 power 0 to 2 power 15. So 1 byte equal to 8 bits. So 2 bytes equal to 16 bits. So the value ranges from 2 power 0 to 2 power 15 can be stored. As it is an signed, it is split into two halves. So minus 32,762 plus 32,767. Similarly, when I go for unsigned integer, the size is 2 bytes, that is from 2 power 0 to 2 power 15, that is by 65535. Up to 65535 we can store. Similarly, when I go for integer as 4 bytes, it starts from 2 power 0 to 2 power 31. So I can store values from 2 power 0 to 2 power 31. As it is signed, it splits into half, negative values of, positive values of. When it is unsigned, only positive values from 2 power 0 to 2 power 31. That is the value here. Similarly, we can say it as unsigned long int, long int, unsigned long int. So we can go for multiple things. This is for integer. Now when I go for character, what I can say, I can give char. We know character size is 1 byte. I can store values from minus 128 to plus 127. That's all. Similarly, when I say unsigned char, the same value, but it starts from 0 to 255. Some of these two things. That's all. So signed character will take same thing. Will take value from minus 128 to plus 127. Because 1 byte equal to 8 bit, so I can store value from 2 power 0 to 2 power 7. So when I go for float, it can store up to 6 digits after decimal point. Double, it takes 15 digits after decimal point. The size is 4 bytes for float. Double, 8 bytes. Okay, so these are all the data types. Okay, let me take a program, let me declare those values, and let me get the let me print the values. So as we know, the program starts with the header file, or I can say preprocessor directive hash include stdio.h. So int main. Okay, now I'm going to store an integer value. Okay, so first I'll take a data type called short or int, anything I can give. So I can give short a equal to 323. I have to give a semicolon. Semicolon states that we are in the end of the statement. Now I will go for unsigned int. B equal to, when I say unsigned, you should not have negative values, right? So I can give 349. To show the difference, I can give minus here. So a value is having a negative value. Unsigned it will not have a negative value. Only positive values we can store. Similarly for long, I can store big values like okay, I'll take some big values. Float. So I'll give float d equal to 3.14. So if you want to mention it as float, you have to give f at the end, so that compiler can get to know this is a float value. If you're not giving this, float also has decimal points, double also has decimal points, so compiler will have a confusion. So that's why I have to identify it very easily. I'll give f, so that is a float value. Double, I can give some value like 3.141592653 goes on like this. So I'll give like this. Then character, we have a data character, right? So I'll give character f is equal to, so whenever I say character, it should always be enclosed with single quotes. So I'll give character a, capital A I'll give, that's all. So I have given all the values. So here this we call it as data type, and this we call it as variable. So variable is a thing, but I'm going to store the value called -323 in one particular place. That is what called as variables. So here a, b, c, d, e, f are called as variables. Before the variable I have given the data type. So when I am giving a data type, I can also include a modifier also to define the range or size of the particular data types. Okay. Now I want to print. So if you want to print, you have to know a concept called format specifier. Okay. So for example, I want to print an integer value. So short, whatever it might be, if you want to print an integer value. So for that you have to use a format specifier called %d, comma a. Let me give a semicolon and let me give return 0 and let me run the code. See here I have got -323. So here it states that %d is an integer value. Okay, so I have printed this. Now I want to print unsigned integer. Now I want to print unsigned integer. So I have to give printf %u. So format specifier, and then I'll give the variable p. So if you want to print something, you have to know two things. I have to give the format specifier first, and then which variable value I need to print. So here a is a variable value, and this value is of an integer type. So I have to give format specifier %d. I'm going to print the value of b. This is of type unsigned int. So I'll give the format specifier %u. I want to print a long value. So long is also an integer, right? So for that I have to take printf. So d states integer. So if it is long, I should give %ld. It states a long value. I'll give c. Now I want to print float value. So printf %f. So %f states that I'm going to print a float value. So the variable d is a float data type. I'm going to print a float value. So the format specifier I have to mention as %f. Then I want to print a double value. Printf %. So f is float. So I'm going to give lf for double. E. That's all. Now character. If I want to print a character, I have to give %c as a format specifier, and then I have to give f is a variable name. This is how I have to print the data types. Let me run the code. So here all the values should be printed continuously because we have not given new line. That is why all the values have been printed. So if I want to print in new line, each value has to be printed in new line. You have to give the escape sequences /n. /n helps us to go for new line after printing that particular content. So after printing an integer value, go for new line. After printing unsigned integer value, go for new line. After printing long int value, go for new line. After printing a float value, go for new line. After printing a double value, go for new line. After printing a character, go for new line. Now let's save the code and run the code. See here, it is an short int value, integer value, long value. So here, instead of long value, I am getting some other value. The reason is nothing but I have given a value which exceeds the long data type. I have given a value which exceeds the long data, because long can store up to 8 bytes. So 8 is a 64, 2 power 63, that is the maximum value. 2 power 0 to 2 power 63, that is the maximum value it can have. But I am trying to store more than that, so it is giving me some other value, because it forms a cycle. Again it starts from 0, so it starts a cycle. So I'll reduce the value. Okay, now this is a long value. When I run the code, see, I've got the exact value 234203448.